So today we can start module 3 of advanced concrete technology, that's fiber reinforced concrete. So here we have to study about what is fiber reinforced concrete, then what are the type of fibers used, what are the advantages of fiber reinforced concrete, then we have to learn about the behavior of fiber reinforced concrete in compression, tension, etc. So, concrete which is made with hydraulic cement containing fine and co-segregate and also discontinuous fibers is called fiber reinforced concrete. These fibers can be made from either natural material or they are available as a manufactured product such as glass, steel, carbon, polymer, fiber, etc. Now, why fibers are used? Main role of fiber is to bridge the crack that develops in concrete, so thereby increasing the ductility of concrete elements. And also, there is an improvement in the post-cracking behavior of concrete containing fiber. Then they also reduce the permeability of concrete and thus reduce bleeding of water. Okay, then some types of fibers produce greater abrasion and also shatter resistance in concrete. Then it also impart more resistance to impact load. Now, what are the advantages of FRC? High modulus of elasticity for effective long-term reinforcement. Then it won't rust easily or corrode and require no minimum cover. Then ideal aspect ratio, which makes them an excellent thing for early age performance. Then what is ideal aspect ratio? It is nothing but it's a relation between fiber diameter and length. Then another advantage is that it can be easily placed, cast, sprayed, and also less labor intensive than placing rebar. Then it have higher flexure strength, depend on the adhesion rate. Then it can be made into thin sheets or irregular shapes, and FRC possesses enough plasticity to go under large deformation once the peak load has been reached. So it can undergo large deformation. Now learn about type of fibers. Different types are the steel fibers, then glass fibers, synthetic fibers, then natural fibers, etc. Okay, so you can learn about glass fiber first. Property of glass fiber is it is having high tensile strength. So tensile strength value range from about 1020 to 4080 Newton per mm square. Then generally fibers of length 25 mm is used. It shows addition of glass fibers shows improvement in impact strength, then increased flexural strength, ductility and resistance to thermal shock. It's also used in case of what formwork, then swimming pools, duct, etc. And also in sewer pipelines, etc. We are using glass fiber. So this is the figure showing glass fiber. Synthetic fiber, that is man-made fibers for petrochemical and textile industries. They are cheap and also abundantly available, and they have high thermal resistance, high melting point, then low modulus of elasticity, and its type are acrylic, aramid, carbon, nylon, then polyester, polyethylene, polypropylene, etc. So this is the figure showing synthetic fiber. This is polypropylene fiber and this is aramid fiber. Then natural fibers, they are obtained at low cost and low level of energy using local manpower and technology. Then jute, coir and bamboos are examples. Then they may undergo organic decay. And they have low modulus of elasticity and also high impact strength. So this is the figure. First one shows cotton fiber, then jute fiber, bamboo fiber. Now various factors affect the properties of FRC. Now let's just check about what are its factors. One is volume of fibers, low volume fraction, less than 1%. So they are used in slabs and pavement that have large exposing surface leading to shrinkage cracking. Then moderate volume fraction between 1 and 2%. So if the addition of volume fraction is between 1 and 2%, then it is used in construction methods such as shotcrete. If it has a higher volume fraction that is greater than 2%, then it is used for making high performance FRC. Then next, aspect ratio. Aspect ratio nothing but fiber length by fiber diameter. It also affect the properties of FRC. Now orientation of fiber. Orientation means fibers can be aligned in the direction of load and also in the direction perpendicular to the load. Okay, so oriented fibers are strong when you pull in the fiber direction, and they are weak when they are at right angles to the fiber direction. Next, it is relative fiber matrix. So the fiber should be significantly stiffer than the matrix. Okay, and low modulus of fibers impart more energy absorption, while high modulus of fibers impart strength and stiffness. So fibers with low modulus is nylon polypropylene, and those with high modulus of elasticity is steel, glass, carbon fibers, etc. Next factor is workability and compaction of concrete. Usage of steel fibers, higher aspect ratio and non-uniform distribution of fiber will reduce workability. Then, prolonged external vibration fails to compact the concrete. This property can be improved by increasing water cement ratio or by using water reducing admixtures. Next, it is size of coarse aggregate. Size is restricted to 10 mm. Friction between fiber and aggregate control the orientation and also distribution. Then mixing. So mixing required careful precautions. That is why, because in order to avoid bearing effect and also segregation. So chance of occurrence of segregation is high. Therefore mixing need careful precautions. Then increase in the aspect ratio, then volume percentage and size of coarse aggregate will automatically increase the difficulties. Next, we have to learn about the stress strain behavior of fiber reinforced concrete. So stress strain curve for fiber reinforced concrete and unreinforced concrete